Good afternoon. How are you today? Great, great. So my name is Tony Xing. I'm Senior Product Manager of Cloud AI Group within Microsoft. So I have been working on various big data and AI-related projects in the past several years. Project Anomaly Finder is actually one of my latest projects I'm working on. Now we are announcing the live for the Project Anomaly Finder as a lab of cognitive service. So before I dive into detail about the Project Anomaly Finder, so just want to step back and provide a lot of some of the context about the motivation why we are doing this, right? So nowadays, a lot of companies are using data to make a decision, to make decisions and improve their products and understand their service health better, understand their product better. But the problem is that there's a lot of data out there, and you want to understand the insight very quickly, especially the bad thing, when bad thing happens, right? So how we can automate this process to find out whether there's something wrong happening. So that's where the anomaly detection come into play. So anomaly detection is really the technology behind Project Anomaly Finder. So before I go to Anomaly Finder, just a quick survey. Show of your hands, how many people have heard of anomaly detection and understand this technology? Okay, several people. So then I think let's do anomaly detection 101. So anomaly detection actually is a pretty well researched domain in academia and also widely used application in this industry. So today we are actually going to talk about a subset within anomaly detection domain. So it's basically time series anomaly detection. So it's basically the problem is that is there anything strange, anything weird? So whether my value as of now is not supposed to be, right? So that is the problem anomaly detection is trying to solve. And then you can actually picture that in this screen, right? So it's basically a line chart. For people, a human being is pretty obvious. There's a huge spike, and you can think of that as anomaly. So the anomaly detection is really how we can automate this process for the machine to understand whether any data point is anomaly or not, right? So basically, for doing those, we basically need to take the input of time series of past history and use that to build a model, and use the model to do the prediction. And if there are anything significantly different from the prediction, then we think that it's an anomaly. So then what exactly is Project Anomaly Finder? So it's a new lab of cognitive service just launched on Build. And it's an API service built on Azure. So it's a REST API. You can use that with any language, with for example, Python, C#, Java, everything. So we have that enough sample on our documentation side. So the input output is pretty much very straightforward. So basically, you give us a time series in a given time range, right? And then the anomaly detection engine hosted in cognitive services basically take that historical input and build model, use that model to do the prediction, detection, when to see is there anything out of historical pattern. And then we'll just give you the enough input. You can use that to do the post-processing. The input we provide, the output we provide include the original time series and also whether a given point is an anomaly or not, and then the expected value and the upper bound and lower bound you can use to do the visualization. And I can show you later on with some of the code sample. Okay. So what you can build with this API. So I can, the API is pretty much very generic. It can be used across a lot of industry like, finance, technologies, transportation, healthcare. So any industry, they care about the metrics and care about what something goes wrong, they can actually leverage this. I'll give you two examples. For example, if you are advertising company, you track your daily revenue streams, and then you want to be alerted if anything goes wrong, right? So because those are the money, you don't want to lose money. So basically, the first chart is basically we can visualize and detect how if there are any data point has been shown some of the dips or spikes in some cases. So we will also draw provide you the upper bound, lower bound value so that you can draw like the purple shade over there. So anything out of that shade is pretty much is anomalies. And the other example is basically if you are a technology company, you care a lot of about your service health, right? And there's a, for example, you can give us the input of the error counters, and then we can pretty much detect anything has been wrong, and there's a sudden spike or level changes. So basically the pattern changes, we can detect that with the APIs. Okay. So let me just give you some example about what the input data looks like. For example, the input is very straightforward. It's just a JSON format. It has actually two fields. One is the period. The other is basically an array of data points, a time series, right? So and then you give that this as input in the request body. So you post that to our API endpoint, and then we will be able to output the following in the response body, right? So basically, the period part is that we can detect automatically what's the seasonality of this time series. For example, we think that is with a weekly pattern, so it's a 7. And then we will give you the expected value and whether this is anomaly. So here's there's a several category of anomalies. Anomaly underscore positive is basically, for example, some use cases only care about the spikes. So you may want to use that. And some use cases, you only care about the dips. So you use the anomaly negative. If you care about both spike and dips, you use anomaly. So we also provide upper margin and the lower margin. Those parameters just for you to draw on the chart the visualization to help you to visualize, what's the deviation from the expected value, the boundary should be like. Okay. And then here I'll just switch to the Jupyter Notebook, and let's do some demos with the Jupyter Notebook. So as I said earlier, so basically our API is a REST API, so you pretty much can use all the languages. So here is basically JSON languages, Python languages. So there's some prerequisites. So you need a subscription key to be able to call this API. And right now, as a lab, so this API is totally free. You can try without any cost. So this is our project main page. So to get the subscription key, you click here. Since I already has been subscribed to that, so there's actually a sign-in step. You use your Microsoft account to sign in, and this will create those subscription keys. So for example, the project Anomaly Finder, this will give you 2 keys. You can use either of them. And copy those keys and paste that here. Yeah. So basically here is you paste the subscription key here. And the endpoint is you can find is our endpoint. You can find in our documentations. So here we will analyze the sample data called sample.json. I will load it from my disk. So it's pretty much contain the similar format I showed you earlier. It's basically a time series with 1 month of data or more than 1 month of data. This first block of the code is pretty much just a load, call the API and load the samples and call the API and get the response. So that is pretty much what you are interacting with our API. And then the rest part is pretty much just a visualization about how this looks like, the response looks like. So before I go to the response, so it's look like this. So one of the interesting aspects of time series anomaly detection is that different from other, the machine learning project like the face API, because for the face API, you pretty much can determine the, whether this face is sad or happy. So different people have pretty much the same opinion, right? But for the time series anomalies, depending on different use case, different people actually can have different opinion whether this point is anomaly or not. So we have to have this sensitivity come into play. So because even for the same time series, if you put it in a revenue stream or if you compare with the same time series in a service health domain, people could get different perception about what's anomaly or not. So here our code just not only generalize, not only show you these anomalies, and also we provide the upper bound, lower bound, and you can adjust the sensitivity, and you can see dynamic results about, so that you can adjust the different tolerance of the anomaly detection, and then you could potentially, reduce the number of anomalies shown from these APIs. So how do you do that? Let's go back to the code. So remember, our code returned to you the upper margin and lower margin. So that is something we provide to the developers, that you can define your sensitivity parameters. You can use that to times the upper margin or lower margin and generate different sensitivity boundaries. For example, I from the code here, we just use very straightforward. Use the sensitivity times the upper margin and lower margins, and plus or minus from the expected value. and then we can just dynamically adjust this upper bound and lower bound so that you can have different sensitivities to even the same time series, right? And then let me see whether I can show another example. So let's load a different and run again. Yeah. So this one is actually a daily is is a time series with a granularity of a daily data point. So we can do actually the same by adjusting this sensitivity. So the code I show here is not the only way you can adjust. You can definitely define by your own, depends on your business case. And you can define different steps to tune this anomaly detection, right? So it's all up to your own. So our API will just first return to you by our own default settings, and then you can tune that based on your own business needs. Okay, so that's all for my demo and presentation. So I'm not sure if you have any questions. Okay, if no further question, then thank you for your time, and I really appreciate that.